want to talk about some technology, that is ICT and computer science. The subject is, so this main topic is involves ICT and computer science. We're studying either of the subject. Now, today I want to talk about the number system. Now, every number has different way of representation. So the number system is simply the set of rules and symbols of representing a number. And you know that we have different number system which can be classified by using through the number of symbols used in representing them, which are called the base and the radix. Like in case of base 2, represented with a maximum of 2 symbols. Base 10 represented with a maximum of 10 symbols. Base 8 with a maximum of 8 symbols. Now, another thing you need to know is that the maximum number in every number system is always less than the radix or the base number. And every numbering system starts from 0, which is why the number of symbols must always be, so which is why the highest number in every number system must always be less than the maximum number of radix or the base number. Like in case of base 2, since the numbering system starts from 0, which is represented by 2 symbols, so we're going to have 0 and 1. But you are talking about base 2. So you see that? So 0, 1, base 2. And this one here, which is the highest number, is less than 2. Same goes for 10, from 0 to 9. Now, these different base numbers, they are also represented they also have what we call powers. Like let's take for example the number 2, 3, 4. See? Here, 4 has the power of 0, and it's in the 0. Here, 3 has the power of 1. In the base 10 number system, and it's in the 10. Here, 2. In the 100. Well, we can also have decimals. That is the 10th, the 100th. We can have up to this point 2, 5. Here I want to have negative 1, negative 2. So this number in terms of power can be represented as 2 times 10. Since we're talking about base 10, 2 times base 10 to the power 2 plus 3 times base 10 to the power 1 plus 4 times base 10 to the power 0. Let's just create this decimal platform now. So this 10 to the power 2 is 100. You can try it on your calculator. So here we have 200. 10 to the power 1 is 10. Yeah. On top to the element to the power is simply the number of times multiply the number. Like here in case of 10. So when we mean 10 to the power 2, I want to have 10 times 10. Multiply 10 by itself 2 times. Here 10 is not going to be multiplied. And here to the power 0. On the store logarithm, we're talking about this. 10 to the power 0, and everything else to the power 0 is 1. This is the main thing you can know for now. I will give you more explanation this when we're talking about logarithm in our next mathematics tutorial. So here we have 30, and since everything raised to the power 10, so since everything raised to the power 0 is 1, here we have 4. So we're now having 234. So now, another thing we need to know here is that we have what we call most significant figure and least significant figure. Like in this case here, the least significant figure is the particular figure or symbol which has the highest power when you multiply by the base. So here the highest significant figure here, or the most significant figure here is 2, and the least significant figure here is going to be 4, which is in the base times 10, which is 10 to the power 0. Now, you need to know another thing. Computers do not understand our own numbering system. They understand only ones and zeros. Okay? They understand only ones and zeros, which is base 2, zeros and 1. Now, how do they get to understand what we present to them. That is what I want to be talking about, the base 2, which is the one used for communication. And we will also be talking about base 16 in the next tutorial, in the next videos, which is used for memory allocation. So let's take any number in base 2, for example, you run a number 1, 0, 1, 0. Now the power C applies here. So we'll start from the listening figure, which is the one further to your right. We have 0, 1, 2, 3. So this is first of all, let me talk over this to base 10. Now I will explain to you how the computer will convert this to this base 2 for it to easily understand it, as it does not understand our own language. So yeah, it's still okay. It's the same procedure. But you work base 10, so you're going to work out in a base 2. So we have 1 times 2 to the power 3 plus 1 times 2 to the power 2. Oh, sorry, here is a 0. Plus 1 times 2 to the power 1. Since this is 0, everything multiplied by 0 is 0. We're going to include this. Now, 2 to the power 3 is simply 2 times 2 times 2. So you multiply 2, you have 3 times. And 2 times 2 is 4, times 2 is 8. So we have 8 plus 2 equals to 10. Now, I will not go into detail into the complexity of how this is converted to base 2. I will look at that in the next tutorial, but I will just explain to you that when you enter this, maybe you enter something in your computer or you put in 10, this number goes to the CPU. Is this 1010. It is converted to base 2. Okay? It's converted to base 2, which is now being processed by the computer. So in the next video, we'll start talking about base 2, addition, subtraction, and then we'll talk about other base, which is octal, and then hexadecimal. See you in the next video. Please, if you enjoyed this tutorial, consider subscribing and give me a thumbs up for this video, which many people like you all would like to study. Okay? See you.